Hello Amartyan, my name is Manoj Kumar. Now I am uploading second video. In previous video, we have done two topics of same chapters. The chapter name is Quadratic Equations. And in previous video, we have done introduction and one method to find the solution of quadratic equation, that is factorization. Now in this video we will discuss second method which is used to find the solution of quadratic equation, and the name of method is quadratic formula. It is very important formula to find the solution of a quadratic equation. Sometimes we are not able to find the factors of quadratic equation. Then this formula is very helpful to find the solution of quadratic equation. So I think you can understand the importance of this formula. This formula is not important only in this class, but in higher classes we can use same formula. Now I am going to explain what is quadratic formula. We already know what is the general form of the quadratic equation, and once again the equation of quadratic form is ax square plus bx plus c equals to 0. This formula we can apply if you can find the value of b square minus 4ac is greater than equals to 0. It is very important step. If v square minus 4ac less than equals to 0, then we will not get real roots of the quadratic equation. So that's why it is very important. If you will get b square minus 4ac is greater than or equals to 0, then you can find the roots of quadratic equation, and the formula is x equals to minus b plus minus under root b square minus 4ac upon 2a. It is very important, and learn it again and again. Now I am going to solve example number 10 by using quadratic formula. Before start this example, please read the statement of example number 11. Question is, find two consecutive odd positive integers and sum of whose square is 290. Once again, please read it very carefully. We need here two consecutive odd positive integers. So, what you will do? First, let us suppose the first required positive integer be x. Then, second positive integer will be x plus 2. Now, according to questions, the sum of whose square is 290. So therefore, we will get x square plus x plus 2 whole square is equals to 290. Now, you will expand x plus 2 whole square, and then you will get x square plus 4x plus 4 equals to 290. And then simplify this equation, and after simplification we will get 2x square plus 4x minus 286 equals to 0. And taking 2 common, and after common you will get here x square plus 2x minus 43 equals to 0, which is the quadratic equation in the form of x. Now, what you will do? You will compare this quadratic equation with general form of quadratic equation, and you will get the value of a is equals to 1, b equals to 2, and c equals to minus 143. Now, you will use here quadratic formula. And what is the quadratic formula? We know that x equals to minus b plus minus under root b square minus 4ac upon. When we will put the value of a, b and c in this formula, you can see the value of x is equals to minus 2 plus minus under root 4 plus 572 upon 2, which is equals to minus 2 plus minus under root 576 upon 2, and the square root of 576 is equals to 24. Now you will get here two cases, one case for positive and one case for a negative. Minus 2 plus 24 divided by 2, you will get 11. Then second case is minus 2 minus 24 divided by 2. Then after simplification, you will get here x equals to minus 13. But we will ignore negative integers. So therefore, our first positive odd integer is x equals to 11. And what will the next? That is 13. So if you want to check the required positive integers are correct, so according to question, you will do the square of both and then add, and we will get the sum of them is equals to 290. Students, I hope you are understand how to use the quadratic formula to find the roots of the quadratic equation. Now we are proceeding further and start example 13. In this example, we will find the roots of the quadratic equation if they exist using the quadratic formula. Here they have given one condition. What is the condition? If they exist. What is the meaning of this line? If they exist. In the beginning of this topic, there is a one relation. The relation is b square minus 4ac, which is equals to d and known as discriminant. If the value of d is greater than or equals to 0, then quadratic equations are existed. And now, before find the roots of quadratic equation, we will check our quadratic equation is existed or not. Now I am going to start the first part of this example, and the statement of this part is 3x square minus 5x plus 2 equals to 0. In very first step, we will compare the given equation with general form of quadratic equations, and after comparing, you will get the value of a equals to 3, b equals to minus 5, c equals to 2. And here we will find the value of d, and we know that the value of d is equals to b square minus 4ac. After putting the value of a, b and c, you can see that value is equals to 1, and which is greater than 0. So we can say here the quadratic equation is existed here, and then we will use here quadratic formula, and we know that what is the formula? That is x equals to minus b plus minus under root b square minus 4ac upon 2a, and substitute the values of A, B and C in this formula. And then here we get two values of x. First for positive sign and second for negative signs. After putting the values of A, B and C, we get here 5 plus minus under root 1 upon 6. For plus, we get the value of x is equals to 1, and for negative, we get the value of x is 2 by 3. So, required roots are 2 by 3 and 1. In same way, we will solve second part of same example, and the statement of the quadratic equation is x square plus 4x plus 5 equals to 0. After comparing the general form of quadratic equation, we get here the value of a equals to 1, b equals to 4, c equals to 5, and put the values of a, b and c in d, and we know that the value of d is b square minus 4ac. After substituting the values of a, b, c, here we get the value of d is minus 4, which is less than 0. Since here we will say it has no real roots, so therefore we are not able to find the roots of given equation. After solving the example, now we will start exercise 4.3, and you can see this exercise is totally based upon quadratic formula. Read very first question of exercise 4.3. Find the roots of the following quadratic equation if they exist by the method of completing the square. You know very well this method, completing the square, is not in our syllabus, and we will not solve first question. Now I am going to start question number second, and in this question we will use same parts which already given in question number 1, but here we will use quadratic formula to find the roots of the given equations. Now you can see the very first part of it. This is the first part of the second question, and the statement of quadratic equation is 2x square minus 7x plus 3 equals to 0. In very first step, we will write down the general form of the quadratic equation, that is ax square plus bx plus c equals to 0. Now we will compare the given equation and general form. From here we will get the value of a, b and c. A is equals to 2, b equals to minus 7 and c equals to 3. In second step, we will find the value of d, which is equals to b square minus 4ac, and now put the values of a, b and c. After substitute the values, we will find the value of d is equals to 25, which is greater than 0, and it means the quadratic equation is existed. Now we will use here quadratic formula to find the roots of a quadratic equation, and we know that the formula x is equals to minus b plus minus under root b square minus 4ac divided by 2a. Now in next step, you will substitute the values of a, b and c in quadratic formula, and you will get the value of x is equals to minus into minus 7 plus minus under root 25 upon 2 into 2, and then the square root of 25, which is equals to 5, and the value of x is equals to now 7 plus minus 5 upon 4, and after this we will get here two values of x, one for positive case and other for negative case. For positive case, the value of x is 3 and for negative case the value of x is 1 by 2, which are our required solutions of a quadratic equation. In same way, we can find the rest of the part of question number second by using quadratic formula. Now, I am going to start question number third. And you can see in question number third, here again we will find the roots of a following equation. Now this time your statement is x minus 1 upon x is equals to 3, where x is not equals to 0. Now you can see the solution of same part. In very first step, you will find the LCM of left hand side. After getting the LCM, that is x, and you will get x square minus 1 in left hand side, which is equals to 3, and then do cross multiplication. Now students, we are going to start question third. In question third, again we will find the roots of following equations, and our given statement is x minus 1 upon x is equals to 3, where x is not equals to 0. In this question, firstly we will solve its left hand side. In left hand side you can see there is a one rational number, that is 1 upon x, and we will solve its left hand side by taking LCM, and after LCM we will get here x square minus 1 upon x is equals to 3. Now by cross multiplication your right hand side will be equals to 3x. Now your quadratic equation will be x square minus 3x plus 1 equals to 0. After getting this quadratic equation, we will solve this quadratic equation by using quadratic formula. Now, in second part of question number third, again both sides, left hand side and right hand side, they are in rational form, and we will solve its left hand side by taking LCM, and the LCMs of its left hand side is x plus 4 into x minus 7. After simplification, you will see the left hand side will be here x minus 7 minus into x plus 4, and which is equals to right hand side, that is your 11 upon 30. Now you will off the brackets in left hand side, and x are cancelled because both are equal and in opposite side. You will solve its denominator. After off the brackets, you will get here x square minus 7x plus 4x minus 28. After simplification its left hand side, you will write down it is equals to 11 upon 30. Now again you will add the constant minus 7 and minus 4 in left hand side. You will get here minus 11, and after simplification in denominator you will get here x square minus 3x minus 28, which is equals to 11 by 30, and you can see in left hand side and right hand side 11 is common, so we can cancel them. After cancellation, now your left hand side is equals to minus 1 upon x square minus 3x minus 28, and right hand side is equals to 1 upon 30. Do cross multiplication, and after cross multiplication our given equation is equals to minus 30
equals to x square minus 3x minus 28 and shift your left hand side to right hand side. And after shifted, now our quadratic equation is equals to x square minus 3x minus 28 plus 30 is equals to 0. And after simplifications, you can see our quadratic equation is x square minus 3x plus 20 equals to 0. After getting this quadratic equation, now we will use here quadratic formula to find its solution in same way.